Hey everyone, in this video we are going to try to describe a quantitative distribution. I have a little acronym set up that will help you along the way. When you are describing a quantitative distribution, it's one of the most important things in the class, truly. So there are four things to consider to describe a distribution. The first one is shape. The next one is outliers. We also need to describe the center, where's like the typical value of the data. And then the last one is spread. How spread out is the data? A couple things real quick. So the shape we talked about in the previous video, things like skewed right, skewed left, bimodal was one, symmetric another. So that's what we're going to look for. Outliers are data that look like they don't belong, and it's really just a judgment call at this point. We'll come up with some rules to define those later on in the course. Center is a very important topic as well. We'll just look for the typical value, we'll look for peaks, and we'll just use those to describe it. And then later in the week, I'll explain some more formal methods to define the center of a distribution. And then spread, a lot of the times, you might see it described as variability. But the spread for us will just be the difference between the largest value and the smallest value. Okay, with all that said, let's describe the shape of heights of students that took the stats class survey. So we have 19 observations, and we're actually going to use a calculator to create the histogram today. Histograms are super important and an easy way to describe shapes. They will tell you more information than just a dot plot. So I'm going to use a TI-84 to do this. If you can get your calculator, maybe pause the video and try to get this data into the calculator, that'd be a good starting point. So anyhow, to enter data into a calculator, it's almost like a spreadsheet. So right here, you should have a stat button. So hit stat, and then if you hit enter, it will bring up lists. And this operates very similar to a spreadsheet. So we are going to put all of this data into list number 1. I already have it filled out for you. Again, you probably want to pause the video and get the data entered. And all you have to do is type the value, like just do 36, hit enter, and then go down to the next value, type the number in, hit enter, and this is what it looks like if you were doing it. So 36, enter, the next height is 58. I missed one of my 62, so I had to put it way down here at the bottom. But again, you should have 19 values altogether. Okay, so to do the histogram on a calculator, there is some pre-work that we are going to do. So first, hit y equals, and make sure you don't have any functions here. If you do, at least hit enter on the equal sign, and it should not populate anymore. We don't want any of these things on. Okay, with that said, we need to go to stat plot. So hit second, and then go to y equals. All mine are off right now, which is fine. I'm just going to go into plot number 1, hit enter, and turn it on just by hitting enter again. The type, there are a lot of different types. Probably the scatter plot is the default choice. But again, we are doing a histogram for this. So just scroll over to the histogram picture, hit enter, and down here it's asking you, where do you want the data to come from? So we typed in all of our heights into list number 1, so that should be populated, that's perfect. And then the frequency, I really doubt that we'll ever change this, but it's just asking you how many times do you want to count each observation. Okay, so now that we have all the data entered, we've got our stat plot turned on, we can graph it. So just go over here to the top right, hit graph, and you're probably just gonna have a coordinate plane. So to get the histogram to show up, hit zoom, and then scroll down until you see zoom stat. On the calculator I'm using, it's option number 9. So again, just find zoom stat, hit enter, and your histogram should populate and look very similar to that. It has some limitations. It doesn't tell you what frequencies they used, but you can hit trace and see that, okay, so like a height of 36, it looks like they called off the interval here at 43.8. That happened one time. So this has a height of 1. So they're plotting just frequencies, and this height happened one time. We can scroll over, or well, we can go here, of course. So this is everything less than 51.6. The smallest amount right here is 43.8. So in this interval, we had 0 observations fall there. This interval looks like it goes from 51.6 to everything less than 59.4, and there was 1 height in this range. So that was the student that was 58 inches tall. 36 inches seems a little bit off. I think someone must have wanted to type 63, or they are 3 feet tall. Okay, anyhow, 9 observations were in this interval, and this interval ranges from 59.4 to everything less than 67.2. So whenever you're creating your histogram on paper, you would want to include these intervals on your x-axis and plot the frequencies here on the y-axis. If you want to do relative frequencies, just take 9 and divide it by 19. I think relative frequencies are a lot better when you're comparing different groups. Frequencies can really kind of get in the way. So 7 in this interval, and then we had 1 person that was taller than, or 75 inches or taller. So 1 person there. Okay, hey, so let's go ahead and describe this histogram. I would probably encourage you to go ahead and sketch that on paper. Again, try to figure out where the widths go. The x-axis, again, is height. So where the heights are going. And then we're plotting just frequencies on the y-axis. Essentially counts, right? So we've got a height of 1. We have a gap, another height of 1. I meant to go over further. Dang it. Height of 9. So 2, 4, 6, 8, maybe up here. Go like that. The next one is, how many were in the next one? The next one was 7 observations fell there. Like right here. The joys of not doing this ahead of time. Extend this out a little bit. And we have one more interval that had just 1 observation in it. Okay, so one thing that you might want to do whenever you plot something like this is to create a density curve. I know I talked about this recently, but you're just trying to kind of smooth out the data using a curve. So we kind of got this peak right here, and we go back down. It's kind of a weird looking distribution. We'll describe the shape here in just a second. So again, one more thing is create the intervals down here on your x-axis. And you can find that again on your calculator. Like this one will go from 75 to 82.8. Goes from 75 to 82.8. So 1 person fell in this range. Okay, so let's go ahead and just start describing the shape. What is this shape? Is it skewed? Is it unimodal? What is this? So the shape. How I would describe the shape, and this is one thing that you're definitely going to do on your AP exam. If you're shooting for a 5, you always need to add context. It's just assumed. It's never going to ask you to add context. You're just going to do it all by yourself. So the shape, the height of students, the height of students, appears to be if I was to omit this kind of part of my curve, it looks like we go up, we reach this peak, and then we start to fall back down. So I'm actually thinking we could draw a line right around here, and about half the data would be on this left side, and the other half would be on this right side. So I'm going to say the height of students appears to be roughly, I know it's not exact, it appears to be roughly symmetric. I'm not seeing any massive skewness there. if our heights, if we would have had a lot of people fall in this range and our density curve looked more like this, then I would say, well, there's a tail to the left and then it's skewed left, right? So anyhow, that'll be good for the shape. The height of students appears to be roughly symmetric. So the next thing, and I'm just using this key up here, don't forget your socks, even though it's not spelled correctly. So the next part, anyhow, is outliers. Are there any outliers present in this data set? So again, an outlier is any value it looks like it doesn't belong. So I think we can all agree that there is one column that looks like it is very out of place. So there is an outlier in this data set. There's one outlier. Here, let's write it out like this. There appears to be one outlier. Again, you're not just going to say 36. We're going to add a little bit of context here. Student with a height of 36 inches. That height right here certainly looks like it does not belong. Okay, so we'll move on then. We need to find the center. Again, later in the week, we'll do a more formal definition of this. But for anyhow, the center, what is like the typical value? We have a peak. Looks like the peak kind of reaches its summit somewhere right around here. So if we go back to our histogram, again, I just hit trace to kind of bounce between these columns. I would say right around here is our peak, somewhere in between 59 and 67 inches. And then we have kind of the next largest peak right here. So I would say the center, or the typical height for a student, is approximately, we haven't calculated this, we are really just guessing at this point, it is approximately 67 inches. Seems to be around the most common height. Everybody seems to be centered around that, and then our data gets more kind of spread out. Lastly, we are going to identify the spread. So this is the easiest thing to do. It is just, you take the maximum amount and you subtract the minimum amount. So we are not going to use 82.8. We know that there isn't a student that was 82.8 inches tall. I can't remember what the minimum was here. I probably should have filled this in for you, but I think you can do that by yourselves. So the spread, the maximum height was 75. So heights vary by. Josh, let's do it real quick. So the maximum amount again was, if you ever need to leave the graph, by the way, just hit second quit. 75 minus the minimum value in our data set, which was 36. So we vary by 39 inches. Heights vary by 39 inches. And again, we found that just by taking the maximum amount of 75 and subtracting the minimum amount of 36. Okay, let me just verify. I think that's all I want to talk about in this video. Hopefully the histogram is a little bit more clear now than it was in the previous video. And again, try to memorize how you describe a distribution. You're going to follow this format every single time. They might be called different things. Like I said, spread might be called variability, but that's going to do it. Thanks for watching, guys. See y'all in class. Bye-bye.